The problems that had question marks on them were like number one, which let's take a look at it. That's number one. I presume you have the book for that. And it said find the average velocity from 0 to point 2. So average velocity is s of b minus s of a over b minus a. And they wanted from 0 to point 2. So point 2. So we need the distance at point 2 minus the distance at 0 over point 2 minus 0. And looking at the table, the distance at point 2 was 0.5. So this is 0.5 minus the distance at 0. Looking at the table, I get 0 over 0.2 minus 0, which is 2.5 if you pull out your calculator. And then it says we need to have units. Well, the distance, if you read the directions, say given in the table is it's feet. So this is the change in feet. And this is change in the time. And the time was in seconds, it says in the table. So this is feet per second. And you'll get the right answer there. Estimate the velocity at point 2. Well, there's lots of ways to estimate that. But just looking at the table, 0 to 0.5, we have a change of 0.2. We have another change of 0.2 in time, but the distance increased more. Went from 0.5 to 1.4. So there's a greater distance gained in that second 0.2 of a second than the first 2 cents. So it's going to be more than what we just got. We had 2.5, so it might be 3 or 4 or 5. Or we could do the average over a bigger interval, like maybe go from 0 to 0.4. And that would give us the average for across that, which might be a better answer. But that's the idea for 1. 3. 3 said this first one says find the slope between 0 and 1. Between 0 and 1, because f of 1 is how high it is at 1. F of 0 is how high it is at 0 over 1 minus 0. So we have the change in the height, these two subtracted, over these two subtracted. Compute each of the following. Now we're supposed to plug those into the numbers, so if we put 1 into this equation, we get 9 minus 1, which is 9, or 8, and put in 0, we get 9. So we have 8 minus 9 over 1 minus 0, which is 1. Which is negative 1. And then if we do f of 3 into f of 3 is, because we're supposed to do f of 3 minus f of 1 over 3 minus 1. 3 in here is 1, or 9 minus x squared. 3 in here would be 0 minus 8. I put 1 in here, I get 9 minus 1, which is 8, minus, over 3 minus 1, which is minus 8 over 2, which is negative 4. And from 0 to 3, in here is 0, minus 0 in there is 9, over 3 minus 0, which is negative 3. So the slopes are negatives, negative 1, negative 4, negative 3. The first one was from 0 to 1. 0 to 1, the slope would be the red D, put down here. From 1 to 3, 1 to 3, the slope is this line, goes from this height to this height, which is C, the blue C. And the final one from 0 to 3, 0 to 3 is D, the green one. Okay. 4. For each interval, we're supposed to, for each of these intervals, which function has the greater rate of change? So let's just kind of look at it. From 0 to 4, 0, the height is 0. At 4, the height is 0. So the average rate of change, well, it went from a height of 0 to a height of 0. There's no rate of change, 0. From 0 to 8, 0 to 8, it went from a height of 0 to a height of 0, so there's no change. So those are both average rates are 0. From 0 to 2.2, it went from here to there. So that's got a rate of change of that slope. From 5.2 to 6.1, 5.2 to 6.1 goes from this point to this point. That line looks a little steeper than this line, so that's a higher rate of change than that one. So far, that's the highest. That's the second highest, and these are 0. 5.2 to 6.9, it goes from this height to this height. That's a slope of 0. So we have a slope of 0, slope of 0, slope of 0. There's 3 smallest. This one's bigger, and this is the biggest. Okay? That's what they kind of want you to be able to do on that. That's what I wanted you to be able to do on that. And number 6. So we have this bungee jumper. And they gave us a formula, the position. Oops, bring it down here where you can see it. Is 100 cosine of 0.75 t e to the negative 0.2 t plus 100. They made a graph of it. And then they said, what is the change in vertical position between 0 and 15? Well, if we go out to here to 15, it looks like it's about 100. And at 0, it's 200. So it looks like it's a negative 100 change. But you could also put in 0 in here for the t's. Cosine of 0 is 0, so all this is gone. The cosine of 0 is 1. 1 times e to the 0 power is 1. So this is 100 plus 100. So at the beginning, it's at 200. S of 0 is 200. And S of, what was it, 15? Yeah. Now I'd have to pull out my calculator. So I'm going to bring out my calculator and type in this crazy formula. See if I can get it where it doesn't have much glare on it. And we're going to type in clear 100 cosine 0.75 x instead of t, close parentheses, e to the negative 0.2 x down plus 100. Enter. And if I go to second table set, put it on asks, go to second table, and go delete, 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 delete. I can put in 0 and check my answer, 200. I can put in 50. I get a little over 100, 101.25, and if I 101.25, and it asks, what is the vertical change in position? That looks like 98.75 feet. That's the vertical change in position between those two times. Estimate the velocities between 0 and 15 to start with. So that would be the change in distance, 98.75 over the change in time. 0 to 15, it's 15. So I'd take and divide those. 98.75 divided by 15, and I get 6.5833 feet per second. Then they said do it from 0 to 2. 0 to 2, so I put in 0, I'd have to put in 2. Second table, put in 2. So it goes from 100 to 104, 200 to 104.75. That's 95.25. Change, that's the change in the distance over the change in time. That was from 0 to 2, so that's 2 seconds. So that's whatever that comes out to be, feet per second. And 1 to 6 and 10 to 8. I think you can get those figured out now. On which interval do you think the bungee jumper receives her greatest average velocity? 0 to 15 has a slope like this, that's negative. 0 to 2, that's a slope like that, that's very negative. 1 to 6, 1 to 6 is here, that's negative. And 8 to 10, that's negative. So the greatest would be the smallest negative, and that would be from 8 to 10. Very steep and gets less and less. Oh, I guess no, 0 to 15 is pretty slight. 8 is here, 10 is here. That's going down about that steep. That's less. 0 to 15 has the least steepness. Okay? On what intervals do you think the bungee jumper receives their, estimate the instantaneous at 5. Well, to do that, I would pick 2 points really close to 5 and figure out the slope of that. So let's do that on the calculator. Go to the table. Let's pick a number close to 5. 4.9. And that would be 67.683. And just past it, 5.1. 72.039. So the change in distance would be this minus this over the change in time between 4.9 and 5.1 is 0.2 seconds. And calculate that out, and that would be my estimate for the average velocity at 5. And E. A Among the average and instantaneous velocities you computed in earlier questions, which are the positive and negative, what does a negative velocity indicate? Negative velocity is going down. The only instantaneous one we did with here was at 5, and it's positive, and that was going up. It was positive because that minus that is positive, and that's positive. All the other ones were negative, and they were going down. Okay? And that's the main ones that people had questions on that still were confused.